Hi! In this lesson, we'll take a deeper look at static variables and methods. We previously learned that static methods are methods in Java that can be called without creating an object of a class. To create a static method, we simply need to include the keyword static in the method declaration. This indicates that the method can be used by the class name itself, and not necessarily through a class object. If we wanted to create a method that reminded us of the different equations that we could use with rectangles, we could create a static method that printed both the formula for area and perimeter. Now that method public static void rectEquations exists, we can call it using the name of the class it belongs to. When rectangle.rectEquations is called, it executes the method even though there is no existing rectangle object. We learned in more detail about the math class, which is a class that contains only static methods that can be used to help with mathematical equations. Because static methods belong to the class, it's important to note that they cannot access instance variables or non-static methods. When we attempt to include the instance variable width from the rectangle class, or the method getWidth, the program throws an error, indicating that these cannot be referenced from a static context. This is because static methods are not associated with an object, but with the class itself. Static methods can be used, however, with other static methods from the same class. Suppose we wanted to build on the math class and create a specific method that would only square a number. We could use the existing math.pow static method in our method to do so. Static methods can also utilize static variables that are used in the class. Static variables are variables that belong to the class. All objects that are created share the exact same static variables, regardless of changes that are made to the instance variables. To illustrate the power of static variables, we will use an example from our superhero class. Suppose we wanted to keep track of the total number of superheroes that were being created. One way that we could do that would be to create a variable numSuperheroes that tracks the number of superheroes that are being created. Every time that the constructor is used, we can increase this number by 1 to track the total number of superhero objects. We could try to do this using an instance variable. Here we've created the numSuperheroes variable and set it to 0, and created a getter method that allows us to retrieve this information. When the constructor is called, we will add 1 to the numSuperheroes value. The problem with using an instance variable is that the value of numSuperheroes will never increase past 1. Here we see that even though we have created 2 superheroes, the value that is printed from getNumSuperheroes is still 1. Here we can see a live demo of this. Why is it that it will always print 1? The reason is that the instance variable numSuperheroes is tied directly to the object that was created. Remember that instance variables are specific to the object that is being created. Every time that a new superhero is being created, a new numSuperheroes variable is being initialized and referenced. As we can see here, both the Flash and Shazam have their own numSuperheroes variables that are being referenced. Changes to one will not affect the other, so the instance variable is an ineffective way to track the number of superheroes that are being created. Static methods, however, exist across all of the objects of a class. If we were to add the keyword static to the getter method and numSuperheroes, we will get the result that we intended. When creating static variables, it's good practice to use the className.VariableName notation. If for some reason we had created another numSuperheroes variable, this notation helps indicate that the variable that is being called is the superhero static variable, numSuperheroes, and not any other similarly named variable. It's also good to note that static methods can be both private and public, just like instance variables. By using a static variable, we are able to get the intended result. Here we see that the value of getNumSuperheroes is correct after another superhero is created. We use the superhero.getNumSuperheroes notation because it is a static method and needs to be called by the class. We can actually call this using the object names as well. Since every object shares the static variable data, static methods and variables can be used by an object of the class as long as the access is public. Here's a live demo of static variables in action. As opposed to the instance variables, which are exclusive to the reference, static variables are shared across all objects. We can see here that while the Flash and Shazam have their own name and power values, they both share the static variable num superheroes. Now that you've learned more about static methods and variables, let's get some practice using them in the editor.